Hi everyone. Can you hear me? Okay. So let's get started. Cool. Okay. So let's just first revisit that what we have already seen in previous lectures, which means lecture 6 and 7. So if you have any doubt, you can just let me know. So this is, I think, lecture 6, right? Yeah, this is lecture 6 annotated notes. So if you have any doubt here, you can just let me know. So there I just introduced a random variable, discrete random variable, and we have just defined what is discrete random variable, what is continuous random variable, right? Okay. Yes, Prashant, you can ask that out. So here, like I have just given you a few examples of discrete random variable and continuous random variable in this particular slide, right? This particular slide I have taken from Stanford, and these were the few examples that I have taken. Okay. So then in the discrete random variable, we first studied what is PMF, which means probability mass function. So probability mass function is basically something which represents the discrete random variable, which means if you know PMF, then you know everything about the discrete random variable, right? So I hope that is clear to everyone. And then how to find the PMF and all. So we did few questions. So these were the few questions where we have said like how to find the PMF, right? Okay. And then this was one question where like they were just asking about this missing entry, and then I said like you can just add all of this up, and this should be one, right? And that's how we were finding the missing entry. Okay. So yeah, this question was little tricky, little tough, I can say. So were you able to solve it? Like I think I have given this question as an homework and then solve it in the next slide. So how many of you were able to solve it? Okay, Saurav was able to solve it. Okay, that's really nice to see. Supriyo was also able to solve it. Satyam also. Great. Abhay is also saying. So that's really nice. That it was actually a little tricky question. So honestly, that's why I have written tough here. So that just to give you the disclaimer that it is actually a tricky question. So it's really good to see that most of you guys were able to solve it. And I think the answer was C here, right? The answer was C. Okay. Okay. So cool. And then have you solved these questions, or should I need to solve these questions? So there were a few questions that I have given as a homework. I think 1 or 2 questions here. Okay, these questions are done, right? So the solutions were on the next page, so you can just verify the solution also. Now, this was a question number 8, and here also, like we have said few things, and I mean, I have given this as an homework to find out the value of this constant C. So actually, this was the basic questions related to PMF, and to be honest, like I have just found these variations. So although like I have tried to create other variations, but just using the definition of PMF, I think these were the only variations which are possible, right? So I mean, I have also given the joint probability distribution conditional and these things, and one tricky question. So I think these were the easy variations that we have done. Okay, and then we move to the PMF of random variable, which is a function of a random variable, right? So how to find the PMF of any other random variable, which is a function basically. So I hope this part is also done. So how do we find it? We actually collect all the outcomes or all the random variable values which are leading to that particular values. Which means, let's suppose if I want to find the PMF of x square, then I will first list down all the values of x square, and I will collect all the values of x which are leading to 1. And that's how we find out the PMF of this particular variable x square. Okay. So I think this is done. And in this case, like multiple values were leading to 0, multiple values were leading to this 3. So we need to add up all the probabilities. Cool. Is this okay, or there is any doubt here? This is okay, right? Now this was another question that we solved and find out the PMF of x square. And this was one homework. Should I solve this homework, or that was okay? If you want, I can just solve it. Okay, anyone? Okay, that was done, right? Cool. So this particular question I have taken from MIT. There is one video of MIT. So from that video, I have taken this question. I hope this is fine to everyone, right? Cool. So here you first have to find out the value of A. So how to find out the value of A? I think you can just sum all of these probabilities. The PMF value should be 1, right? That's how you can find out the value of A. And that was the AG lecture. Now let's just quickly move to the 7th lecture. So in the 7th lecture, we talked about the expectation. And expectation is one number which actually summarizes the PMF, right? Okay, Prashant, I will come to your doubt in just a minute. So expectation is one number which summarize your PMF. And then that's what this MIT book PDF says, right? The expectation is one number. This is accumulated expectation. Yeah, it would be desirable to summarize this information in the single representative number, which is what expectation is, right? Okay, so we are following this particular book for all of our lectures. So either I say it or I don't mention it, or I mention it. It doesn't matter. Like most of the screenshot, most of the concept, or most of the examples, or most of the things are basically from this book. Okay, so expectation is defined like this, and then we talked about expectation of some questions. So here in this question, expectation of this X, and I think yeah, we talked about few expectation, right? So there was one doubt that Twinkle was asking in the group. So was that solved, or is it still there? Okay. Okay. So basically, here this -8, I think you were asking something about the -8. -8 is not the random variable value, first of all. Okay, this is I mean, okay, this could be the random variable value. It doesn't matter. So basically, it is basically at number 1 you are losing 8 rupees. It is like that. I don't remember your doubt, but yeah, it like the explanation is that at number 1 you are losing 8 rupees, like that, right? And then they've asked the amount of money won or lost. So basically, whenever they ask you something, which means whenever they ask you the expected amount or expected something, then always first define the random variable X. So first define X, and then say that X is, let's suppose, amount of money won or lost, and then say that okay, this is expectation of X, right? I mean, like whatever they have asked is actually expectation of X. So first define the random variable X, and then talk about expectation of X. Cool. Yeah. So I think these were some good questions that we have solved. And then we talked about that. What does this expectation really mean? Was that clear? So I actually spent a lot of time in creating that video just to make sure that you understand this particular topic. So was that helpful? I mean, if there is any doubt, just let me know. Okay. Okay. Thank you so much. So there's some nice feedback that I'm getting. Cool. So basically, like to be honest, like I spent a few hours just to make sure that you understand everything, that what is the difference between expectation and average. And I actually started from the very basic definition of the probability, right? So what is the definition of probability and how it is connected to expectation and average? Okay, thank you, Twinkle. So, okay. Now, okay, so I think that is done. Now, then we talked about the expectation of like expectation. Okay, that is okay. The expectation as a center of mass. And then, okay, yeah, this particular question was from the MIT book, and to my surprise, that exactly same question has been asked in GATE, right? They didn't even bother to change the values. I mean, they just change the value. This is 110. I mean, instead of 100, they just put it 10. So, I mean, that's okay. But yeah, they didn't even bother to change the values. The only variation that they have created is instead of 100, they put it 10. Instead of 200, they put it 20. And maybe they were too lazy to solve it again. That's why they have not changed, and they have not changed the probabilities. Okay. So then we talked about the expectation of function of random variable, right? So expectation of function of random variable is basically there were two ways. One is that you first have to like one way is that you either have to find out the PMF first, and then you find out the expectation, right? So which means that you have the PMF of X, and then you want to find out the expectation of X square. So how to find out the expectation of X square? Either you first find the PMF of X square, which we already have done, and then you find the expectation of X square by taking it as by. Or there is some other way, which is basically saying that you use anyone remember the method name, although it is not important for GATE, that name. Yeah, it is Lotus. right? It means that law of the unconscious statistician, something like that. Yeah, law of the unconscious statistician. So there is, I mean, name for this particular method, this method too, and they call it unconscious because the people use it unconsciously. So that's why they even call it unconscious method. Okay, so we have talked about it, and in this method, just remember a very crucial thing, which is that if you are finding expectation of anything, then always write this particular template first. Okay, I mean, the notations doesn't matter, but yeah, always write this particular template first. Where this is same, right? Which means that you are ranging over all the possible values of x, and this is the probability of x. So you just plug in the function after it. So this is the particular template that that I ask you to follow, right? So you can have any function here, maybe gx. But remember, you have to have this particular thing, right? This particular thing. This is always same. Okay. And this is called method 2. That's what we have seen. Cool. Okay. So we have solved few questions related to that method. If you want, I can solve these questions which are here. Should I solve these questions? I mean, I gave these questions as an homework. So if you want, I can solve. Mouse wala question will be uploaded today. Okay. So there was one question that I shared in the group. So that question will be uploaded today. Cool. So I think those all questions are done. If you want, I can just solve any one of them. Do you want me to solve any one of them? I gave them as an homework, but if you want, I can solve. Okay. Okay. Now, if that is okay, now let's just do some tricky questions in the expectation. Okay, some tricky questions in the expectation. So here, like tricky in the sense that these questions are little unconventional. Unconventional means that you won't see these kind of questions too often. So let's just see these questions. Now, to solve these questions, what we will be doing, we will be using something called as law of total expectation, which is basically saying that if you have any expectation to find out, let's suppose you want to find out the expectation of x, then what you can do, you can basically say that you will break down this expectation into two parts, just like law of total probability. So basically, if you want to find out the expectation of x, then you can say that let's just say there is one event A. If A happens, then what is the expectation? Let's suppose this expectation is E1. If A doesn't happen, then what is the expectation? Let's suppose this expectation is E2. And then if I say that what is the expectation of x, E maybe, that is equal to, if A happens, then expectation. If A doesn't happen, then expectation. So if A happens, which means that the probability of A, then expectation, plus if A doesn't happen, which means E2 is the expectation if A doesn't happen, and the probability of A complement. No, these are the expectations. Even one of them could be greater than 1. Okay, I mean, these are the expectations. This could be even 500. This summation need not to be 1. Okay, even the single one could be anything. So here it is very different from what we have already seen as a tree method. So don't try to relate it with the tree method. Okay, here these are the expectations. So I will say that if you want to find out some expectation, then probably you need to break down this expectation into two parts. If A happens, then what is the expectation? If A doesn't happen, then what is the expectation? Let's just see the questions. So this is the question number 1, where I'm saying if you roll a die, okay, you roll a die. If you get number which is greater than 3, you will be winning 100 rupees. Okay, you will get, right? This is you will get. Okay, if you get a number greater than 3, then you will win or you will get. Okay, so this is you will win. You will win 100 rupees. Otherwise, you lose 50 rupees. So what they're saying, that there are two possibilities. Either you win 100 rupees or you lose 50 rupees. So if you get a number that is greater than 3, so there are two events. If you get a number which is greater than 3, if you get a number which is less than or equal to 3, which means if you get a number which is 1, 2, 3, if you get a number which is 3, 4, 5, 4, 5, 6. right? If you get a number which is 1, 2, 3, if you get a number which is 4, 5, 6, there are, let's suppose, two possibilities. In one of the case, which is the first case, that you will be winning 100 rupees. So you will say that you are winning 100 rupees here. And in another case, you are losing 50 rupees, right? Now they are saying what is the expected amount of money that you win or you lose. So it means the expected amount of money they're asking, that you win or you lose. So there are two events, either this happen and this happen. Tell me, aren't these two events exhaustive? Which means that aren't these two events are partitioning the sample space? Either this will happen or this will happen, right? This is A and A complement basically. So you will say that if this happens, the probability of A is, what is the probability of the first event? Greater than 3, I think 3 by 6, because these are the three numbers, which is 1 by 2. This is also 3 by 6, which is also 1 by 2, right? Okay. Now you will say that if this first event happen, maybe this one, then the probability is 1 by 2. And in this case, you will be getting 100 rupees. If the second event happen or the first event doesn't happen, then you will be getting minus 50 rupees. So that's how you can solve this question, right? This is 50 by 2, which is 25. So E is 25 here, which means you will be you will be winning 25 rupees on average. So can anyone tell me intuitively? Can anyone tell me intuitively what does this expectation to be 25? What does this mean to be say that expectation is 25? Suppose you play this game. Then what does this mean? On average, right? On average, this expectation means average. So on average, you will be, if you play enough number of times, then you will be getting 25 rupees. Now suppose you play this game and you play it 10 times. Okay, you go to any club and you have a gambling, and there you play 10 times, and after 10 times you lose all of your money, or maybe you lose, let's suppose, 500 rupees or something, right? So let's suppose you lose some rupees, let's suppose some X amount of rupees. I mean, you're losing basically. Then you come to me and then you will say that that sir, you told me that I will, on average I will be winning 25 rupees, but I'm losing. So what will I say? Yeah. So I will just say that just go and play more games, because you might not have played enough number of games. And then you played, let's suppose you went and then you played, let's suppose, 100 times. And then after 100 times also, you come to me and then you will say that, sir, I lost all of my money. You told me that if you play enough number of times, then you will be winning 25 rupees. But I lost all of my rupees. Then I will say that maybe you have not played enough number of times. Okay. So basically, if you ask me that, okay, I'm losing, I will just say, see, you're not playing enough number of times. Then let's suppose you play it 10,000 times. After 10 yeah, after 10,000 times you go bankrupt. Okay. So there is nothing left with you, your house, your everything has sold away. And then you come to me, you will say that, okay, sir, you told me that you will be winning 25 rupees on average, but now I don't have even any house to live. Then what will I say? See, it is just 10,000. You have not played enough number of times. Maybe play more. You will be definitely be getting 25 rupees at the end. So it's like that. Okay. So don't blame me. I will always say you have not played enough number of times. So don't take the inspiration from these questions. That's the moral of the story. Okay. Cool. Because whenever you ask me that, sir, I'm losing, I will just say play enough number of times, because that's the definition of probability saying. Just do it enough number of times and the probability will adjust for you. Okay. Now let's just solve this question. A professor occasionally employs any of the three students to do typing and such other works. Assume that Alice averages 10 errors per document. So there is one student. So what is happening here? A professor assigns or employs one of the three students randomly. Okay. So if he chooses Alice, then Alice actually does 10 errors per document. Betsy does 20 errors per document, and Claire, okay, how to pronounce it? Clary, right? Okay, Claire. Okay, Claire does 50 errors per document. Okay, Claire does 50 errors per document, suppose. Okay, that is given to me, which means there is a professor. There is a professor who assigns either to Alice or to Betsy or to Claire, right? Now they are saying that that Claire does 50 errors, Alice does 20, and Betsy does Alice does I think 10, Betsy does 20, and Claire does 50 errors per document. Cool. The professor needs a document typed up, and she will give the task to whichever student shows first, which will be Alice with probability 2/5, Betsy with probability 2/5, or Claire जो भी है with probability 1/5. So they are saying that the professor will assign to one of the student if the probability of choosing Alice is 2/5. So professor will choose Alice with 2/5, and here it is 2/5, and this is 1/5, right? 1/5. Now, what is the question? Let X be the number of errors made in the typing the document. Then what is expectation of X? Which means if Alice is given the task, he or she will make the 10 errors. Betsy will make 20 errors. Claire will make 50 errors. Now, on average, how many number of errors that you are making? Okay. So expectation of X. X is the number of errors that you have made. So it is like that. If you choose Alice, which is with this probability, then you do 10 errors. If you choose Betsy with this probability, you do 20 errors. If you choose Claire, then you do 50 errors. So if you sum this up, you will be getting 22, which means on average, you are getting 22 errors. What does this on average 22 errors means? What does this on average 22 errors means? Anyone? Just let me know. Okay. So it means that I'm saying that what does this expectation to be 22? What does this mean to say the expectation is 22? Yeah. So if you repeat this experiment again and again, which means sometimes you might choose Alice, sometimes you might choose Betsy, sometimes you might choose Keller, and you do enough number of times, which means sometimes someone is writing document, sometimes someone else is writing document, sometimes someone else is writing document, and if that has been repeated many times, then if you take the errors in all the documents, then it is 22. If you take the average of all the errors in all the documents, then it is 22. Understood? Okay, cool. So basically it is like you, okay, please show the question. The question में कुछ नहीं है, like it is in the diagram only, like the professor is choosing one of the student and everyone is making either some error, either 10, 20 or 50, and these are the probabilities of choosing them. Okay, so my question is that if expectation is coming out to be 22, then what does this mean to say that expectation is 22? So it means that if you repeat this experiment enough number of times, which means sometimes the professor chooses Alice, sometimes the professor chooses Betsy, sometimes the professor chooses Keller, and then if you do it enough number of times, then you will be getting how many errors? On average, you will be getting 22 errors, right? Okay. That question has been taken from UCI, which is a top university. Okay, let's do this question. This question is taken from MIT book. Okay, so what they're saying that suppose that 49.8% of the people in the world are male and rest are female, which is more or less true. Okay. Also suppose the expected height of randomly chosen male is 5 foot 11 inch. So basically, if you convert that to just foot, it is 5 plus 11 by 2, 11 by 12. Okay, so that I mean, if you want to convert that inch to foots, then it will be 11 by 12. Then while the expected height of randomly chosen female is 5 plus 5 by 12. Now, what is the expected height of randomly chosen any individual? That's what they're asking. See, either you choose male or you choose female. Now they are saying if you're choosing male, then in that case, the height will be 5 plus 11 by 2, 11 by 12. In this case, it is 5 plus 5 by 12. And what is the probability of choosing male? Can anyone tell me what is the probability of choosing male? If you choose randomly, if there are 49.8% people are there, and if you choose randomly, then what is the probability of choosing male? This is 0.498, right? And this probability is okay, 0.502. Cool. So these are the probabilities. Then how to find the expectation? So what they're saying that either you choose male with this probability, then you will be getting this much height. If you choose female with this probability, then you will be getting this much height. So how to find the expectation? Expectation will be equal to 0.498 multiplied by 5 plus 11 by 2, 11 by 12 plus 0.502 multiplied by 5 plus 5 by 12, right? Easy question. So see here that the expectation even means that expected height if you choose the male. And what is the probability of choosing male? 0.498. So that's the formula that we are applying. Is this understood to everyone? That what we are doing? Okay. So see, sometimes it might so happen that this expectation, this even and E2 are given very directly, which means they are giving you directly that this is even. But this need not to be always the case. We will see the example. Okay. So let's just see some example where it need not to be always the case that they give you even this directly. I think in all the questions that we did here, this was given directly, right? This is 10, this is C, this is even, this is E2, this is E3. And all of them are given directly, which is 10, 20, and 50. Right? So here also 100 and minus 50. So everything is given directly, but it need not to be the case. Let's just see some question. So this is a question which is like I can say one of the quite tough question. I can say not very tough, but yeah, it is very, very nice question. Very, very like I can say interesting question. At the same time, it is little tough. Maybe a little tough or maybe more tough. I don't know. Let's just see. But this question I have taken from IIT Madras, and they have that question in their quiz. But I think that course was a master's level course. I mean, that course was, I don't know if that was undergrad or master level course, but yeah, this question is relevant for the GATE. So whatever is relevant for the GATE, we are picking from different sources, right? Okay, let's just read out this question. So what they're saying, 2 balls are drawn from a bag containing 4 balls, numbered 1, 2, 3, 4. So there is a bag. In this bag, from this bag, you are picking 2 balls, okay? Which is, and this is having numbers 1, 2, 3, 4. Now, if at least one of the numbers drawn is greater than 2, then you win 10 rupees. Okay, just listen here. You are bringing you are pulling two balls from here. Let's suppose both the balls are 1 and 2. Okay, then in that case you will not be winning anything. So why? Because they are saying if at least one of the number that is drawn is greater than 2, then only you will 10 rupees. Otherwise you lose the same amount, which means if both the balls are like 1 or 2, then you will be losing 10 rupees, right? Then they're saying that let X be the total amount won or lost, then what is the expected amount that you are winning or losing? So let me just go to the question again. See, what they're saying is that there is a bag. Okay, there is a bag which is having 1, 2, 3, 4. Now you pick 2 balls, one after another. Let's suppose you pick first ball you pick is 3. Okay, first ball you pick is 3. Now, after you pick 3, are you sure that you are going to win 10 rupees? Or do you have to pick anything else? Based on the question, they are saying if any one of them is greater than 2, then you are winning 10 rupees. Okay. So once you pick 3, you are sure that you are going to win 10 rupees, right? Cool. Now, suppose instead of 3, you picked 1 as a first ball. Then are you sure you are going to lose? No, right? You will pick another ball and then you will check that, okay, are you going to lose or you are going to win? How much you will be losing if you are losing 10 rupees. How much you are winning if you are winning? 10 rupees, right? Cool. Now let's just solve this question. So what may so happen that either you will be getting, I mean, as a first ball, either you will be getting 1 or 2, or you will be getting 3 or 4, right? Actually, I don't know the answer, so don't ask me the answer. I really don't know the answer. I mean, I don't remember. I think maybe it is in the next slide, but I don't remember. Okay, so see, when you're picking the first ball, I'm just asking the first ball. The first ball. It can be either 1, 2, or it can be 3, 4, isn't it? Or will there be any other case? Only 2 cases, right? 1, 2, 3, 4. Now, okay, if it is 1, 2. Actually, the next ball that you are going to pick can be 3, 3, 4, can be 3, 4, or can be, I mean, based on that, if it is 1, then it can be 2. If it was 2, then it can be 1, right? Okay. Let's do one thing. I think this combinedly things are not that suitable for this particular case. So let's do one thing. Let me just separate it out as four cases. Okay. So which means, let me just separate it out like a 4 cases. Maybe you are getting 1 at the first ball, maybe 1, maybe 2, maybe 3, maybe 4. Okay. See, I was just trying to do 1, 2 at the same time, but that was making me a little confused. So I'm just making it 1, 2, 3, 4 different possibilities. I mean, you can do any one of the thing, but that's okay. Okay. Cool. So now let's just suppose that the first ball could be anything. This is the first ball, right? First ball could be anything, which is either 1 or 2 or 3 or 4. Now, suppose, okay, Chinmay is here. Chinmay, are you someone who has secured recently a top gate rank, or you are different, Chinmay? No, you are different one. Okay, he's Chinmay Jain. Okay, he's Chinmay Jain. But the way you are answering, then I think you will be definitely get topper next year. Okay, so let's suppose that first ball you are picking is 1, and then at the next ball you can either pick 2 or 3 or 4, isn't it? Let me know if that is okay to everyone. Now tell me, what are the probabilities here? The picking the first ball as 1, what is the probability? If everything is equally likely, 1 by 4, right? 1 by 4. Now tell me, what is the probability here? Will it be 1 by 4 or something else? This will be 1 by 3, right? 1 by 3. Why? Why it is 1 by 3? Because now 3 balls are left only, right? Only 3 balls are left. Cool. Okay. Now if it is 4, okay, I will cover this 2 and 3 just a second. Now if it is 4, then the next ball could be either 1 or 2 or 3, right? And what are the probabilities? 1 by 3, 1 by 3, 1 by 3. Cool. No, but I think I don't need to divide this 4. Because if it is 4, then I think I'm sure that I'm winning some rupees, which is 10 rupees, right? Okay, I will come to this. Yeah. So so let's just come to this case. If it is 1, then I will be picking another ball, and based on the another ball, I will declare whether I'm winning or losing. Now tell me here how much I should write, how much I am winning or losing, or what number I should be writing. If I'm getting 1, 2 edge balls, then what is that number that I should be writing here? I'm losing 10 rupees, right? So it should be minus 10. Here in this case, I'm winning or losing? I'm winning, right? It is plus 10. Here in this case, it is plus 10. Okay. Cool. Yeah, that's great. Now let's just see that in case of 4, what's going to happen? Okay. In case of 4, can I directly write plus 10 here? Can I directly write plus 10 here? Let me know. Because either it is 3 or 4, then you are winning, right? Okay. Now in case of 2, I further have to divide. I can either get 1 or can get 3 or can get 4. But because of symmetricity in the sense that I don't think there is any difference between 1 and 2, right? I mean, whatever purpose that 1 is serving for 2, I mean, vice versa, that 2 will be serving for 1. So I think the tree diagram will be same, even if I expand. So anyway, let's just do one thing. Let me write the numbers here. So see, I have divided my sample space into 4 parts. So I will say, if I get 1, then what is the probability of getting 1? This is the probability of getting 1. So maybe I can write something like this. What is the expected amount of money that I'm winning or losing if I'm getting 1? Plus, what is the expected amount of money I will be winning or losing if I get 2? Plus, what is the expected amount of money I'm winning or losing? Plus, what is the expected amount of money that I'm winning or losing if I get 4? Right? So these are the 4 possibilities. Now, let's just start with this possibility. Now, what is the probability of 1? This is 1 by 4. नहीं ये थोड़ा complex हो जाएगा. Actually, okay, let's just do one thing. Actually, I have divided my sample space in something like this. That in this particular case, so basically these branches are all the possibilities, right? All the branches are all the possibilities. If I just expand this 2 in the 3 branches, then how many possibilities are there? These are the 3 possibilities. These are the 3 possibilities, 6, 7, 8, like that. I mean, if I just say that if I am dividing my sample space, then these are all the possibilities, right? So, okay, with 1 by 4 into 1 by 3 probability, I will be losing 10. Is this okay to everyone? With 1 by 4 into 1 by 3 probability, I will be losing 10. Right? Similarly, with 1 by 4 into 1 by 3 probability, I will be winning 10. Right? Similarly, with 1 by 4 and 1 by 3 probability into 1 by 3 probability, with this probability, I will be again winning 10. Right? So, you can easily check that these two are the same numbers. So finally you got 10 by 12 basically, right? 10 by 12. So from this branch, you are getting 10 by 12. Now, similarly, this 2 is no different from this one, right? I mean, 2 and 1, because of symmetricity, either you say 1 or 2, doesn't matter, I think. I hope that is okay to everyone. So that's why I can have one more 10 by 12. Now, these 2 branches are left only. Now, with 1 by 4 probability, so I will say, maybe I can just write in that way. See, currently I have these 2 numbers, which I got from 1 and 2, right? 1 and 2. Now, what about other numbers? Now, I will say with 1 by 4 probability, I will be winning 10 rupees. Similarly, into 2 you can do with 1 by 4 probability. This is 10 by 4, right? So I think you got 10 by 12 plus 10 by 12, which is 20 by 12 plus 20 by 4. So which is equal to, can anyone tell me? 80 by 12, right? Which is 20 by 3. Yeah. So 20 by 3 is your answer. Have you understood this, what we have done? So basically, we have just created all the possibilities. In what possibility you might be winning, in what possibility you might be losing, right? So these are the 2 balls. So I will say I have just expanded the tree to 2 levels, but not for 3 and 4. Because there is no benefit of saying 3 and 4. Because if I'm having 3 at the first ball, then definitely I will be winning. So I can expand my tree, and I have just calculated. I've just done one thing. I've just multiplied all the probabilities, which is in this case 1 by 4 into 1 by 3, and then this number, because with this probability I will be winning or losing this number. So I'm just multiplying all the branches, right? And how many such branches are there in this tree? 1 to 3 branches, and 3 branches, 6 branches, and here I don't need to expand. So that's why 7 and 8 branches. Right? And for every branch, I'm just calculating with what probability you are doing, or you are winning or losing. So 20 by 3 is the answer. Okay. So I don't have the answer currently, but yeah, I know, I remember the answer, which is 20 by 3. Cool. Is this okay to everyone? Now let's just solve few more questions based on the same method. But these questions are even more tricky. Okay. Which is what we are calling recursive way of finding the expectation. So currently what we have done, we have used that method, which was seeming to be easy. Actually, it is easy after some practice, but currently it might seem tough. See, initially that was the very child version of that particular formula, which means that you were directly having this E1 and E2 and you were solving, right? I just shown you, something which is little better question, little good question. And then now let's just see something even more better. Okay. So let's just see these kind of questions. Okay. There may be some other method of solving that earlier question. So maybe like you may have solved using some other method. You can just post that method maybe in the group, and we can discuss there. If you want, I can discuss here also. So maybe I can just proceed, and at the end of the discussion, we can see other methods which are there, right? Okay. So let's just see this question, which I've taken from some university, maybe that is University of UCI. That is from that university maths department. I have taken this question. So what they're saying, that Clark likes to buy a certain kind of lottery ticket, each ticket independently of other ticket yields one of the following price. So for every ticket, I'm saying for every ticket that like you will be winning 10 rupees with how much probability? With 1 by 20 probabilities, right? You will be winning 10 rupees with 1 by 20 probability. You will be winning 1 rupee with 1 by 5 probability. You will be winning 2 rupees. Okay, this is not rupees. So you will be winning 10 rupees. You will be winning 1 rupee. You will not be winning anything, 0 rupees with 1 by 2 probability. And now they are saying you will be winning 2 free lottery tickets with 1 by 4 probability. So with 1 by 4 probability, you are winning 2 lottery tickets itself, right? So 2 tickets. Now they are asking that what is the expected payoff of a ticket? Okay. So for every ticket, like or on average, how much you are winning? Can you solve this question? This is 1 by 20. So you are saying this is 1 by 20 into 10 plus 1 by 5 into 1 plus 1 by 2 into 0 plus 1 by 4 into 2 tickets, right? So what does this mean to say 2 tickets? See, every other branch is very much sorted. Only thing which is left to right is 1 by 4 into something. Now, what does this mean? To say that, okay, you have won 2 tickets. Just think about it. Let E be the expected number of price. On average, you will be winning. Okay, expected number of price that you will be winning from 1 ticket. Okay, expected number of expected number of price from 1 ticket. And with 10 with 1 by 20 probability, you will be winning 10 rupees. 1 by 5 1 rupee. With 1 by 2 probability, you are not winning anything. But with 1 by 4 probability, you are winning 2 tickets, which means how much you are winning actually in terms of rupees. Can anyone tell me? 2 tickets is okay, but in terms of rupees, see what is happening here. Is, as I'm saying, is the expected rupees from 1 ticket, right? The expected rupees from one ticket. Now I'm asking that what I should be writing here, which means that if I say E, which is the expected number of rupees from one ticket, which is actually something like this, 1 by 4 into what should I write here, and then plus 1 by 2 into 0. So the only term which is remaining is this in this E formula. Is this okay? Till now the things are fine, or there is some issue? So what I'm saying here is that you are winning some rupees with some probability, and that's why I have written this formula, right? And now see, the E is the expected rupees from one ticket. And since you are winning two tickets, which means you are actually winning how many rupees? So we are talking in terms of expectation only. You are winning 2 E rupees, isn't it? See, E is the rupee that you are winning from one ticket. If you are winning two tickets itself, then you are winning 2 E rupees, isn't it? So finally, if you just try solving it, it will be equal to 1 by 2 plus 1 by 5 plus E by 2, right? So from here, can anyone tell me what is the answer? Which is E by 2 equal to, this is a 5 plus 2, 7 by 10, right? So E is 1 by 4. So which means on an average, you are winning from one ticket, you are winning 1 by 4, 1.4 rupees. Is this understood? We can solve it using other method also, but at least this method is understood or not. See, you won two tickets, which means you have won. Since I'm claiming, I'm letting it that is the rupees that you are winning from one ticket. If you have won two tickets, then you have actually won two E rupees, right? So that's why I'm writing 2E. But maybe we can just try solving it using other method also. Okay, don't worry. This is just a starting of this method, and I have many questions using that method. Like even I have the recursive programs just to just to analyze using this method. Okay, so that is the question that I have taken from Stanford. This is the Stanford slide, and which is a recursive program. So we will be doing it, doing many questions, okay, using this method. So it will be very much habitual. And then obviously whatever we are teaching is not just for the sake of teaching. So we will be solving three or two, I think 2 or 3 gate questions, 2-3 gate questions using this method, and one or two, I don't remember exact number. I think two or one TIFR questions. Okay, so there are 3 to 4 questions that they've already asked using this method. That's the only reason, I mean, we are studying this seeming complicated method, but actually it is not. Okay. Okay, Saurav is saying that, can you repeat that earlier method again? See, what I'm saying here, that is the expected amount of rupees that you are winning just using one ticket. Okay, is the expected. Now, if you recall that, what is the total formula, law of total expectation? Basically, it says that E, that is equal to, if this happens, then what is the probability of this? 1 by 20, then you will winning 10 rupee. 1 by 5, with 1 by 5 probability, you will winning 1 rupee. With 1 by 4 probability, okay, I need to write some other expectation here, right? I mean, you are winning some expected rupees, plus with 1 by 2 probability, you will be winning 0. Is this okay to everyone? I mean, at least this formulation, right? Now, what they're saying that you have won two tickets. Now, can you tell me how much expected price you will be winning using those two tickets? How much expected price? See, this is the expected number, right? Which I need to write here. How much expected price you will be winning using those two tickets? So using one ticket, since I assume that you are going to win E price, so expected price using two tickets is 2E. So here, this E1 itself is 2E, right? So that's how you can solve this question, and E is coming out to be 1.4. Now, maybe what we can do here, maybe we can try solving it using some other method. I'm not sure how we can solve it, but let's just see. Okay. So what you got here, like with 1/20 probability, you will be winning this. That is okay. The only problem is in this branch, right? How to interpret this branch or how to solve this branch. Let's just see if we can do it. Now, what will I say? That here you have won 2 tickets, right? With 1/4 probability, you have won 2 tickets. I don't know कि complicate हो जाएगा या फिर नहीं, but should I try this now or after some examples? That also I don't know. Maybe let me just try it now. So see, here you have won two tickets. Now, let's suppose these are the 2 tickets that you have won. Okay. This is the ticket 1. This is ticket 2. Right? Now, using this ticket 1, aren't you having the same conditions again? That with 1/20 probability, you will be winning 10 rupees. With 1/5 probability, you will be winning 10 rupees. So can you take this question? Yeah, if it is okay, someone has sent me some link. So if it is related to this particular concept, then we are going to solve it in 2 days or tomorrow lecture. Okay, is this the same question? Your username is P. Can you send me a screenshot of that question? Maybe. Okay. So with 1/4 probability, you will be again winning 2 tickets. With 1/2 probability, you will be winning 0, right? So with the ticket 1, you will be repeating the same story. With the ticket 2 also, you will be repeating the same story. Is this okay to everyone? With both the tickets, you will be just doing the same thing, and you will be having the same story, right? Now tell me how many branches you have in this case. See, this is 1, 2, maybe you can say 3, and then this is, I mean, how many leaps basically? So 1, 2, 3, 4, 5, 6, 7, maybe 4 here also. 7 plus 4, I can say 11, isn't it? So let's do one thing. Let's just sum up all of these 11 branches. Okay, there is one question. Yeah, these kind of questions we will do. We will do these kind of questions, right? Sorry. So what you will say, the expected amount E is basically again the same thing, which is money, expected money with the one ticket. So what should be the expected money? That E is coming out to be, can you just tell me what should be E? It should be 1/20 into 10 plus 1/5 into 1 plus 1/2 into 0, and then plus 1/4 into all of this drama, right? And what is that drama? 1/4 into 1/20 into 10. So it will be 1/4 into everything, like 1/20 into 10 plus 1/4 into 1/5 into 10 plus 1/4 into 1/4 into again these 2 tickets. So now, like, see, it will be, I think, very complicated. So let me just assume that these 2 tickets is like, I mean, see what we did earlier. We assume that these 2 tickets, not assume, but we have put the value of the 2 tickets as 2E here, right? But in this case, what we did, we have not realized that it is 2E, and we have just expanded the tree unnecessarily, right? No, you can do it. I mean, it will be very complicated. I can do it, but I think these are the 2 tickets, so it will be infinite series. It will be infinite series. But if you want, what you can do here itself, you can realize that it is just 2E. It is just 2E, right? Here itself, you can realize that this 2 tickets is just 2E, and then again 1/2 into 0, and since it is repeating the same thing, so that's why 2 into the same thing, right? Abhay, you must have done some mistake. So let's just continue. Maybe after some example you will get to know, because we will do that method also with some other questions. Maybe you have watched the previous lectures, and that's when probably you're talking about the same method. Okay. Anyway, is this understood to everyone what we are doing here? See, earlier what we did. Earlier we realized that this 2 tickets is just 2e. Will give you 2e, right? And then we stop my tree here. We stop the tree here itself. Is this okay to everyone? But here we have not realized it, and I just try to expand it. Even if you expand it, then let's suppose at this moment you realize. I mean, it is just a point wherever you are realizing. So if at this moment you realize, then you will say that this 2 tickets is just 2e. And you can solve this particular equation also. I guarantee you that you will be getting E equal to 1.4 only. If you want, you can try solving it. So by the way, have you understood what we are doing here? What we did earlier is basically we stopped here because of this 2 ticket recursion, right? We stopped the recursion here, and we said like these 2 tickets is just 2e. But here we are not stopping. We are saying that let's just move one more, maybe one more level, because I have not realized that this 2 tickets means recursion. But let's suppose after one more level, I realize that, okay, this 2 tickets means recursion only. Then also it is fine. I mean, you can just sum up all the probabilities, and then instead of these 2 tickets, you can write 2e, and then you can solve it. Right? And then you will be getting the same answer, which is 1.4. Okay. So 1.4 is the correct answer. Okay. Now, do you want to solve this question? Or, I mean, do you want me to solve this question, or do you want this question to be homework? Because now you should be able to solve this question. So what this question is saying, at least let me just let me just tell you what this question is saying. A mouse is trapped in a room with 3 exits at the center of maze. So basically, it is having 3 exit: exit 1, exit 2, and exit 3. This is a maze. Okay. Exit 1 leads outside the maze after 3 minutes. Exit 1 is basically after 3 minutes, you will go outside. This mouse will go outside. Exit 2 leads back to the room itself after 5 minutes. Okay. Exit 2 is saying after 5 minutes, you go to the room itself. Exit 3 is saying after 7 minutes, you will go to the room itself. Every time the mouse makes a choice, it is equally likely to choose any of the exit. What is the expected time taken by mouse to leave? So let me just go to the next page and let me explain this question properly. So at least let me just explain this question. So what is happening? This mouse is here. There are 3 probabilities, right? Either it chooses exit 1, or it chooses exit 2, or exit 3 with equal probabilities. Okay. Now let's suppose E is the amount of time, expected time to exit. Expected time to exit from room. Okay. If we are standing here, if mouse is standing here, then with 1/3 probability, it will go to exit 1. And in how much time it is leaving the room? Can anyone tell me what is that number I should be writing here? It is 3, right? In 3 minutes, it is leaving the room. If you go here with 1/3 probability, if you go to the exit 2, then what you are doing? That's very important to understand. You are spending 5 minutes. That is okay. But you're again back to the room, isn't it? You're spending 5 minutes, but you're again back to the room. That is important, which means your 5 minutes got wasted. So if you choose this exit 2, then how much amount of time in aspect, how much amount of time or the expected time you will be leaving this room? 5 minutes you have wasted, and then you are in that same room. So how, and as I assumed that E is the amount of time that you take to go out of from this room. So basically, if we are at this room, you take 5 minutes, you are at again at the same room, which means you have wasted your 5 minutes, and then you will anyway going to spend this E amount of time. This is just wasted, right? wasted. And this is basically, you can say, in future, you are anyway going to spend e amount of time, because that's it. That is my assumption, that if you are in some room, in this room, then you spend e amount of time to go out of this room, right? This is my, I mean, not the assumption, this is the definition of e. I mean, that's how we are solving. So this is you just did, and that's what you are going to do in future, because you have wasted your 5 minutes. If you're choosing exit 2, if you're choosing exit 3, you have wasted your 7 minutes. You're again to the same room, right? Again to the same room. Manish is saying, why 5 plus e? Why not 5 into e? Okay, this is a question where I should be asking you that why 5 into e and why not 5 plus e? I mean, you are asking me that why 5 plus e and why not 5e, but I will ask you the reverse question. Why you are thinking that 5e, right? I mean, from where you are thinking 5e? It is just that the amount of time, like, I mean, if at 9 a.m., if I, let's suppose, if it is 11 a.m., this is 2 hours, right? And from 11 a.m. to, let's suppose, 12 p.m., this is one more hour. So this is 2 plus 1, 3 hours, right? Total. I mean, you don't multiply these 2 hours. You just say the 2 plus 1, this is 3. Okay. So basically, we're adding the time. I mean, 5 minutes you have wasted, and in future you are again going to waste, or you are again going to take e amount of time, right? Okay. So Twinkle is giving some explanation that why not 5e, but that explanation is also not good. I mean, that is not correct explanation. So whatever you are saying won't is not making much sense. So basically, it is not 5 into e because it is 5 plus e, because it is time which we are adding. 5 minutes you have wasted, and in future you are going to take e amount of time, right? And here you are going to take 7 plus e time. Is this okay to everyone? The way we are making the tree diagram? Okay. So now what you can do, now you can basically find out this E. How? This E will be 1 by 3 into 1 by 3 into this 3, 1 by 3 into 3 plus 1 by 3 into 5 plus E plus 1 by 3 into 7 plus E. Okay. So I think if you solve it, you are going to get E equal to some number which is 15. Okay. So have you understood this question? This was a nice question, right? This was just to let you know that, I mean, how to solve this kind of question. Has any one of you attempted AIMT 3? All India Mock Test 3? Any one of you? Okay. There was one question actually in AIMT 3, just like that. Not exactly like that, but yes, it was like that. There was one program that I gave you. Okay. So that question was something like that. There was some program, and I think I don't remember the exact question, but there was some while loop. Okay, there was some while loop. I was saying with some probability you go to this particular path or something, and then I was asking that what is the expected number of trials you take to go out of this while loop. This was the question, and here the same question we have asked. Here the same question we have asked in terms of maze, right? I mean, there was a question that I was just asking. In the while loop there was a condition. Okay, in the while loop there was condition: if something happens, then you break this loop. Okay, which means you go outside this loop, otherwise you continue in this loop, and this condition was true with some probability. So basically I was just asking that how much trials you will be making in this while loop, how much iteration you will be doing in this while loop, something like that. That question was really nice. That was in the AIMT 3. Okay, so let me know your doubt here. Supriya is asking, sir, we are able to do this recursion with E because expectation is defined over infinite number of trials. Yeah, basically because of the formula. Basically, the formula says that everywhere you write the expectation, expected number of time. If with this probability, how much expected time you will be taking? With this probability, how much expected time you will be taking? See, the formula itself is saying. See, with this probability, how much expected expectation of what is the expectation on this? With this probability, what is the expectation of this? Like that, right? Okay. So what are the other doubts? Prashant is saying, isn't it strange that 7 plus 5 plus is equal to 15? Okay, 7 plus 5 plus 3 is 15. Let me just think about some logic about it. Seems interesting. I think we can find some logic. No, this might not be a coincidence. Reason being the probabilities are same. Actually, the probabilities are same. That's why I'm thinking that there must be some logic. If that the probabilities are not same, there is a coincidence. But the probabilities are same. That's why I'm thinking that why 7 plus 5 plus 3 is also 15. Okay. Can't think of any logic as of now that why 7 plus 5 plus 3 may be 15. From this E equation, yeah, that is coming out to be 7 plus 5 plus 3. Yeah, maybe you can just try it out with XYZ. Maybe it is XYZ in this case, X plus Y plus Z. Anyway, like let's just focus on the concept. I hope the concept is clear to everyone. Okay, cool. Now, are you ready to do this question? This question I have taken from Stanford, and that's really very nice question. Mhm. One second. Okay. Yeah. So what they are saying, consider the following recursive function int near, and then they are saying that there is a variable b that can take any value between 1 to 4, and every value is equally likely. Either it is 1 or 2 or 3 or 4, right? And okay, first of all, if you are not comfortable with this return, else if, and these kind of things, then don't worry about this question. You can completely skip this question as of now. Okay, skip this as of now. If you're not comfortable with this, the programming syntax, we will learn it in the C programming. Now, what they're saying that if y is a value that is returned by this function near, then what is the expected value of y? Which means that what is the expected value that this near is returning? So I think that's an easy question. If you want, you can try it out. So see, there are four cases, right? Either either b is 1 or 2 or 3 or 4. If b is 1, then what do you return? You return 2. Here you return 4. If b is 3, then you return 6 plus whatever near is returning on average, which is e, right? That's what my assumption is, that e is the amount that near is returning. E is the number that near is returning, right? So this is 6 plus e, this is 8 plus e, and everything is equally probable. So I think this is 2 plus 4 plus 6 plus e plus 8 plus e divided by 4 equal to e. Now from here, you're getting e equal to 10. Okay. So I hope that is fine to everyone. So that's how you can solve this particular question, right? If we take n wage probabilities as same and take n minus 1 wage back to the start, then addition is the answer. Okay. I don't know. So you are saying n wage probabilities as same. Okay, maybe you can we can discuss that those logics on the Telegram group. I'm not currently getting what you are saying. If n wage probabilities are same and n minus wage back to the start, then addition will be same. Okay, you are saying the same thing. You are generalizing the same thing. I don't know. Maybe you can try it out. Yes, exactly, Twinkle. So Twinkle is saying that if we could have gotten this question maybe 1 hour or half an hour before, then this question could have been one of the most tough question. Maybe you will get scared if you directly see these kind of questions in the examination. So see, my point is not to obviously do any complicated or any unnecessary question which are irrelevant to gate. Like everything that we are teaching or everything that you are studying will definitely be related to gate. So we will be solving gate PYQ just using this method. Don't worry. It is just that we have just built some foundation. Okay. So obviously, like every of the concept that we have studied, those will be followed. Like after those concepts, we solve gate PYQs. Okay. So if I'm not solving gate PYQ, it doesn't mean that it is not relevant to gate. It is definitely relevant to gate. Then only we are studying that. Cool. So I hope you understood this. Now, do you would like to try two variations of this question? Do you like to try some variation of this question? Okay. So there is very interesting variation. You might not be able to currently do it, but okay, there is a variation that I also don't remember. That is in the Stanford slide only, and that variation is basically related to two functions. They have not given one function that time. They have given two functions. One was near, another was far. Near is same as it is. Far was actually calling near. Okay, and then they were asking the expected value returned by the far. That was a nice question. We might solve it. Actually, you will be able to solve it after some gate PYQs. So we will be first solving the gate PYQs. And here, like currently, we are just making one equation. If you notice, we are just making one equation of E in all the questions, right? In all the questions, we are making just one equation of E. We will be solving some gate and TIFR question where we will be making two equations of E. Okay, where we will be making two equations of E. And then you should be able to solve these kind of questions. I'm talking about these are the two functions. Okay, we will be solving those two equations question first, and then you can then I will give you this variation as an homework. Okay, so I hope you have understood this particular method. Don't worry, we will be solving more questions in the recorded videos. So but today I just wanted to tell you this method a little bit. Okay, there was some doubt that Prashant has asked regarding the conditional probability. Let me just take that doubt if I can see that. Prashant, do you have that doubt with you currently? Okay. He's saying it was a quiz question, and the drug one where the probability was positive, just drugs. I'm confused that. Have you by the way seen that quiz discussion? I think we have solved that question in the discussion. I don't remember. Have we solved that question in the discussion? Okay, we have not solved this question. Cool. So what you are saying that the drug one where the probability was positive, positive results, test is positive, given that we use the drug, right? I'm confused in that, sir, because the given thing is only given in the question. Okay. Have you seen that video which was related to LinkedIn interview? Yeah, thank you, Satyam. Satyam is saying he has aborted all quiz questions. So thank you for that. Have you seen that video, Prashant? That was optional video. Okay, optional video. And I was saying that it is my LinkedIn interview. Okay, Prashant, if you have not seen that yet, then you can just see that, and then okay, you can just watch that video. Okay, Prashant. So don't skip optional videos. Optional videos are there. If you're preparing, let's suppose some subject in November or December, then you can skip those videos. Now don't skip. Okay. So for now, don't skip those videos. Optional videos are there. Like if you're in the hurry, then only skip those videos. Cool. So anyway, you can watch that video and your doubt will be clear, because this is the same question. And also I have recorded one test series question. I have recorded one test series question, and that is test series question solution. That is exactly the same question. You can watch that solution also. So once you give the probability test, you will be seeing the video solutions of every question that we are going to put. Okay. Because you always give questions from those optional videos. Okay. So okay, the optional videos are there just to escape if you are in a hurry, which means if you are preparing in October or if you are preparing in September, if you are in very hurry and your syllabus is too much left, then only you watch the you skip those optional videos. Okay, good. So that's all I wanted to discuss today, and then I will be continuing with more examples in the in the recorded video. Okay, cool. So thank you everyone. Thank you so much. Take care. Bye bye. Yeah. Thank you, Saurabh. Okay.